In Chapter 8.3, we'll look at combinations. Let's start with exploration 1 to see how they differ from permutations. So we'll start with our group of 7 students from the previous section. For simplicity's sake, I'll just call them students A, B, C, D, E, F, and G. Now, suppose these students are running for a student council where the positions are president, secretary, and treasurer. We're asked to determine the number of ways the student council positions can be filled from this group, and are then asked if the order in which they are elected matters. Well, if we have 1, 2, 3 positions, then we could have any one of the 7 students in the first position, so we have 7 options here, and then any one of the 6 remaining in the next position, and then any one of the 5 remaining in the third position. Now, the question of whether or not the order matters has to do with the roles. And what I mean by that is the first position represents a president, and the second position represents a secretary, and the third position represents a treasurer. So if, for example, we had student A in the first position, and then student B in the second position, and student C in the third position, would that be different from if we had student B in the first position, student A in the second position, and student C in the third position? And the answer is yes, it makes a difference, because in one case you have A as the president, and in the other case you have B as the president. So these student councils are distinct and distinguishable. They are different from one another. All right, so here we would say that yes, the order matters. Oh, I suppose I should multiply this together first. 7 times 6 times 5 makes 210. And yes, the order matters. Next, after filling the positions, there are 4 leftover students. Let's suppose they were students A, B, C, and D. From these 4 students, we're going to select 3 as student council advisors. Again, we are asked, does the order in which the positions are filled matter? Well, this time we have 3 positions to fill, but they are all equivalent, which means if you had student A in the first spot, and then B in the second spot, and C in the third spot, that would not be different from B in the first spot and A in the second spot, because the first and second spot represent the same thing. They just represent a member, a general member of the council, not a specific or titled member. And so in this case, we haven't yet figured out how we're going to determine the numerical value of how many groups or options that would give us, but we could say here that the order does not matter. So again, when we have specific roles or titles, order is relevant, and when we have equivalent roles with no titles, it will not matter. We're going to see a lot of committee questions that will be combinations. So we're asked here, list each of the possible 3-member advisor groups that can be formed from 4 leftover students. Now, I'm going to leave this as an exploration for you, and I'm going to show the result in the next slide. But try to write out all the possible 3-member advisor groups you could have from students A, B, C, and D.